Okay, so right now we're looking right at the part that says applications of logarithms, and what we'd like to do before right as you click on that, instead of watching this, we'd like to have the video that Tom's sending you, and as he plays it, we will talk about applications of logs, just like we'll talk about applications of exponentials, rich with applications. Logarithms are everywhere. Richter scales,
Shape
pH, chemistry,
pH,
we see them everywhere.
Give some sort of animation.
The one thing that logarithms do for us is logarithmic functions enable us to write take a very large scale and make it a very manageable scale.
Okay, stop. So what I'm thinking is this huge number line going from 0.001 to a million on a linear scale, and then and have little markers, like you were saying, like a red, blue, green, yellow, whatever, and then when you shrink from a linear to a logarithmic scale, see that they get less real estate, they're packed in, and these guys are a little bit further apart, but somehow we're trying to get a visual for them. Then, when we go into, and so that's with my talking head, but then when we launch, when we actually get to this piece, which I don't think you need now.
Right. So,
except for when we get to when we get to Richter scale, pH, and decibels, I think, I would actually have examples of that. So like when you see dB, have something loud to a whisper. When you have earthquake, you can have a little tremor and a kind of tremor. And the same thing on pH balance, right? So acid rain and something very basic. So that's what I'm trying to think of in terms of giving them physical quantities to think about when they're thinking about that.
Bring the applications to life.
Correct. Bring the applications to life. And so this particular example is on sound. So when we get into this, you'll see a table that talks about like a vacuum cleaner, whisper, a jet engine. I think it'd be really cool if, like even here when you say threshold, her voice should even lower to the very minimum threshold of hearing for humans, kind of bring that down so they get there. They're having multiple senses now. Their hearing is helping, their audio is hearing them. And then when you see the chart, have it like go through the chart, like one line light up, and if it's the vacuum cleaner, you hear a vacuum cleaner. If it's the jet engine, you hear a jet engine. If it's an iPod, you hear somebody's music or something. Just to try to bring it more to life for them. When we do get to the logarithmic scale, in this particular example, and you might just want to go ahead and click on it, Tom, is here, what I feel like is there's no value added from the animation. I'm trying to add value from the animation side. And so all of this can go away or be sound. But when you get to the point where we're talking about frequency is inversely related to wavelength, what would be interesting is, and it goes very quickly, and Tom, you can go a little bit further this way for them. Again, this is, if we showed this on a linear scale and then brought it down to a logarithmic scale, so what I'm thinking of here, this goes way too quickly, let me just slow this down. I do like the snap though. But once we fill these in, okay, we could take the points slowly. So but we could do this on a linear scale and then bring it down to a log scale, and then they'll see it. If we actually did this on the linear scale, these would be bunched together, and so it would be inversely related. But they should see a point. They should see this point go to here, this point go to here, and a slower. And you could use color for pedagogical reasons. So like this blinks red, this point becomes red. This blue, this becomes blue. Leaving the colored points on there, having it linear, and then shrinking it to a logarithmic scale. So that's log. And when you get to the log plot, you'll see that the graph actually goes from something that looks nonlinear to something linear. That's an intuitive thing they will learn as engineers later in terms of what a linear, semi-log, or a log plot looks like. Okay? Is that good? Okay.
Great.